Syed. Today's topic will be the continuation of the previous video. In the previous video, we have discussed about convolution theorem. Let us move on to the next question. Using convolution theorem, obtain the inverse Laplace transform of the function s by s square plus a square whole square. So once again you have to write down the value of f bar of s as well as g bar of s. So how can I write this value, because only one s is there? So can I write this as 1 by s square plus a square? I'll show you over here. It is s by s square plus a square whole square is there. So in the denominator you can get s square plus a square, one expression, into s square plus a square. This is how you can write. So here s is there, either you write s into 1 or 1 into s. So which means I can divide 1 by s square plus a square, one value will be your f bar of s. Or s by s square plus a square, its value will be g bar of s. So either you take f bar of s as s by, or you take f bar of s as 1 by, any form you can take. So I have taken f bar of s to be 1 by s square plus a square, and g bar of s I will take it as s by s square plus a square. So we got this value, f bar of s and g bar of s. But we know f bar of s is nothing but L of f of t. So this is nothing but 1 by s square plus a square. G bar of s is nothing but L of g of t. So it is s by s square plus a square. Now let us try to find out the value of f of t and g of t. So f of t value will be equals to, take L on the other side, becomes L inverse of 1 by s square plus a square. And here g of t will be equals to, so L goes on the other side, becomes L inverse of s by s square plus a square. So let us try to evaluate this one. So we know this formula, L inverse of a by s square plus a square, its value is sine of at. So if you try to observe here, it should be a by s square plus a square. So a is missing. So I will multiply by a over here and divide by a, so that it gets in the standard form. The second result, we know L inverse of s by s square plus a square. So its formula is cos 80. This is standard form. So since it is in the standard form, there is no need to change anything. So now if I put it over here, f of t value will be equals to 1 by a as it is. This L inverse of a by s square plus a square will be how much? Sine of 80. Then you have g of t. G of t will be equals to L inverse of s by s square plus a square. What is its value? Cos of 80. So we got f of t and g of t. So once you get it, now because in the convolution theorem we require this f of u value and g of t minus of u value. So keep this value ready, which means t has to be replaced by u. So it is 1 by a sine of t has to be replaced by u. So t will become u. So a times of u. So here it is cos of a into, here t, in place of t what you have? T minus of u. So replace the value of t by t minus of u. So t minus of u. Or if you try to multiply, it becomes cos of a into t will be at minus a into u will be au. So now if you use the convolution theorem, convolution theorem is L inverse of f bar of s into g bar of s will be equals to, it is integral of u is equals to 0 to t, it is f of u into g of t minus of u into du. So now if you try to plug in L inverse of, I know the value of f bar of s. So the value of f bar of s, that that I have taken is 1 by s square plus a square into g bar of s I have taken s by s square plus a square. That is equals to integral u is equals to 0 to t. F of u value is how much? 1 by a, it is sine of au. G of t minus of u is nothing but cos of, it is at minus of au into du. Or I can rewrite this as 1 by a, it is integral of u is equals to 0 to t. It is sine of au into cos of at minus of au into du. So now we have to use the formula sine a cos of b. Sine a cos of b. So the formula that we have for sine a cos of b is nothing but half times of sine of a plus b plus sine of a minus of b. This basic formula you have to remember. Sine a cos b will be nothing but 1 by 2 times of sine a plus b plus sine of a minus of b. So if you use this formula back over here, so I will be getting 1 by a into integral u is equals to 0 to t sine of. So this value will represent, this au value will represent your a value. This at minus au will represent your b value. So it is sine of a plus b, 1 by 2 as it is, 1 by 2 times of sine of a value is au plus b value is at minus of au plus sine of a minus of b. So sine of a value is au minus, because minus sign is there, I'll take it common outside, and b value is at minus of au. Alright, it is sine of a plus b plus sine of a minus of b into what you have into du as it is. Or half if I take outside, it becomes 1 by 2a. Alright, it is integral of u is equals to 0 to t. So here you can see that this plus au and minus of au will cancel out. Alright. Or further, if I try to simplify this one, this is sine of at here plus, here you have sine of au minus of minus plus au. So au plus au will be 2au. And this is minus of at as it is, minus of at. So times of what you have, times of du. Now if I try to apply integral separately for each of the terms, I will be getting 1 by 2a. I need to apply the integral. So because here integral is with respect to u, so you don't have u here. So sine of at is a constant. So I will take that outside and write integral of u is equals to 0 to t times of, you multiplied the u inside. So I have applied the integral for this first term. Next, plus. Now once again apply the integral for the second term. That is integral of u is equals to 0 to t. It is sine of 2 times of au minus of at times of what you have, du. This will be equals to 1 by 2a times of, it is sine of at. Integral of du will be u, and the limit values that you have is, limit value is from 0 to t. Then plus, now integration of sine, we know integration of sine is minus cos, so we'll be getting the value to be minus cos of 2au minus of at whole divided by, I have to take the coefficient of u, so coefficient of u is 2a, and the limit values u will be 0 to t. So let us try to apply the upper and lower limit values over here. So this will be equals to 1 by 2a. This sine of at will remain as it is. So upper limit value for u will be t minus lower limit value for u will be 0. Then here plus into minus will be minus 1 by 2a. You can take common outside. Apply the upper limit value for u to be t. So it is cos of 2at minus at upper limit. minus the lower limit for u will be 0. So cos of u is 0. So the first expression is 0 minus of this 80. We applied the limits. Now let us try to simplify this one. So this will be equals to 1 by 2a. It is sin 80 into t will be t times of sin of 80. Here minus 1 by 2a as it is. So cos of 280 minus 80 will be 80. And here minus of, you have cos of minus 80. But we know cos of minus of theta is cos of theta only. Basic formula, cos of minus theta will be cos theta. So here cos of minus 80 will be cos of 80 itself. So what happens over here is plus cos 80 and minus cos 80 will cancel out. So you are left out with 1 by 2a times of, it is t sin 80. So both have cancelled out and you are just getting 0 here. So therefore you have the value to be equals to, it is t sin 80 divided by 2a. On the left hand side you have L inverse of. So if you go back to this expression over here, so left hand side what you have, L inverse of 1 by, just multiply it, s into 1 will become s divided by a square plus a square into a square plus a square will be a square plus a square whole square, which will give you the question itself, s by a square plus a square whole square. This will be equals to how much? It is t sin 80 divided by 2a. So that's the required solution.